So we're going to be graphing these. I want at least 5 points on your graphs. We're going to be looking at odd and even functions. If you have an odd exponent, or if it's going in different directions, like one is rising and one is falling, then it'll be an odd function. If it's going in both directions on the ends, then it would be an even function. Okay, so we're going to look at this first. And again, if you don't have a graphing calculator, you're going to have to pick values for x. I would pick these values. And you're going to plug them into your equation and find the y value. Now, if you have a graphing calculator, you can just type it in, and you can fill in the table based on your graphing calculator. So go to y equals. Now, there's a little caret button right here that will help you raise it to anything that you want as far as the exponent goes. So if I want to go x, then raised to the 5th power, then I have to arrow out of that, and then minus 2 on the end. Now, you can push graph, and this is what it'll look like. So it's increasing. Notice it's increasing from negative infinity to positive infinity. So that would be the domain of which the function is increasing, because it's going up like that. But then I want you to go to your table. So second graph, and I want you to fill in the table these points right here. So negative 2 would be negative 34, which would be off your graph, obviously. Negative 1 would be negative 3. 0 would be negative 2. 1 would be negative 1. And 2 would be 30, which again would be off of your graph. But these are the points that I would like you to graph. So let's say negative 2, negative 30 would be way down here. But then you can get on the graph negative 1, negative 3. Then 0, negative 2. Then 1, negative 1. And then 2 would be up here at 30. So you would come in here, you would follow your points and arrows on both ends. So I do want at least 5 points on these. Now, the domain that is increasing, it is increasing from negative infinity to positive infinity because it stretches, there's no break in the graph, okay? So that's what you're going to be responsible for doing, is graphing these and then answering some questions on the first part of your homework, okay? But again, if you don't have a graphing calculator, you're going to have to put in, start with negative 2. Negative 2 to the 5th power minus 2 is going to be negative 34. Then go with negative 1, plug it in. But I do want points for you to get credit for that, okay? Okay, let's do a couple more of these. This would be an odd function because the end behavior is going towards negative infinity and this one's going towards positive infinity. So when that happens, even if it's reversed, if that was a negative x to the 5th power, it would still be an odd function, okay? If it's going in both directions, if both ends are going in both directions, the same direction, then it would be an even function, okay? So let's look at an even function. This is going to have both ends of the graph going in the same direction. And these are both going to be going up because the number in front of your function is positive. It's technically positive 1. If that was a negative, then both ends would be going down. Now, technically, there's going to be some turns in the graph, okay, before both of them start to go up or down. Well, if you take away one of the exponents from x to the 6th power, this would turn 5 times before it started to both go down, okay? So if you want to know how many terms there are in the problem, just take one less than the exponent, and that's how many times the graph should turn around. Now, you may not see it quite on the calculator, but you will be able to state that if you were asked that. Okay, so let's look at this one. We know both ends are going to be going up. This will be an even power, so let's type it in. And then the raised to 6th power. Now I push graph. Both ends are going up. Now, it kind of looks like it turned a bunch of times before it went up, but the pixels in this calculator you can't really see. Okay, but I still want you to, if you don't have a graphing calculator, these are the points that you're going to pick for x and plug them in. Okay, so let's go to the table, and those of you who do have a graphing calculator, -2 is at 1, -1 is 0, 0 is at 1, 1 is at 64, obviously way off the graph, and 2 is at 729.
Can you show how you got to that again?
Got the table?
Yeah.
Okay, so here's graph, right?
Mm-hmm.
Go second graph, and there's your table. Got it? Okay. Okay, so we know what the graph looks like. So -2, 1, -1, 0, 0, 1, 1's way up here, and 2 is obviously way up here as well. And then if you went -3, it's at 64, which is way up here. So we can start up here, and then we can go down. And it must have turned a bunch of times in here, but we just can't see it. So I'm okay with that being your graph. And then you can see both ends. We're going to talk about the end behavior on both sides. We have a right side and a left side. And both are going towards positive infinity. So we'll talk about the end behavior in a second, okay? Okay, this is a third power, so one end is going in one direction, the other end is going in the other direction. So that's going to make it odd, all right? So this one is reversed from that first one. Because it's a negative in front, the left side will be going up to positive infinity, and the right side will be going down to negative infinity, something like this. But again, pick your values for x. You can type this in the calculator. Don't forget to use a negative instead of a minus sign when you're doing -2. All right, so we got -2, then parentheses, x minus 1, raised to the third power, then we got +3. All right, so let's look at what this looks like. Okay, it does go backwards from the odd problem that we did at first when it was positive. So go to your table, so second graph, go to -2 is 57, which is going to be way off. -1 is at 19, 0 is at 5, 1 is 3, 2 is 1, and then 3 is -13, which will be off the graph. Okay, so when you graph this, you're going to go -2, and then up here, somewhere up there, would be 57. -1 and 19 would be somewhere right here. Then 0 is 5. 1 is 3. 2 is 1. And then 3 starts to go back down here. So you're really coming up, going through your points. And putting arrows. And so this one would be decreasing. it starts and goes down low. Okay, so that's how I want you to graph these. You will have a few to graph on your homework, so practice that, okay? Now, this next part of the notes, you may want to, just jot down what's in yellow, because that's going to tell you about the range and the domain. So, there is no restriction for x for the domain. That's why all of these functions, unless it's a fraction or has a square root, there won't be any restrictions for x. So they'll be all real numbers for the domain. So that ought to be fairly easy when you're asked for that. Now the range for odd degrees, like the ones that go in different directions on the ends, they're going to be all real numbers as well. But when you start getting the even ones where they both go either up or both go down, then you have to figure out where's the lowest point on the y that it started, and then where's it going to go. Okay, so I'll show you that. But the first part is deciding whether it's even or odd. So when you're looking at this again, if both ends are going in opposite directions, like this one, if this right-hand side is going up and the left-hand side is going down, those are going to be odd functions. Okay, when they both go in the same order or same direction, like C and D, both sides of C go up and both sides of D go down. Therefore, it's going to be even. Okay. So that ought to be fairly easy to remember. So this one is odd. This one is odd, but it's negative because it's going in the other direction. Both going in the same direction, even. Both going in the same direction, even. They want to know the function is even or odd based on the graph. So if it's odd, for example, if the exponent was a third power, a fifth power, any odd power, and it's positive, it's always going to go this way. Okay? If it's an odd and it's negative in front, then it's automatically going to go the opposite way. It kind of reflects over the x-axis. Okay? Same with even. Let's say you had a second power, a fourth power, or a sixth power. Both of those sides are going to go up. If it's even and they're going down, then the function is negative. Okay? So now, when we do this end behavior, what's happening on both ends? Where is it going as you're approaching positive infinity or negative infinity? Well, both of those are going down towards negative infinity along the y. So you don't necessarily have to graph these, you just have to kind of know what they look like based on the odd and the even part of the problem. So you really don't have to graph these last parts. These are determining the end behavior, and you have to write the end behavior like I'm going to show you. So make sure that you do that. Okay, again, all of these functions, you do not have to physically graph them. You just have to know and draw a little sketch maybe to show, okay, what is it doing? Because you're going to have to describe what's happening on both ends of the graph. So look for the highest exponent. All right, this is an odd power, and the number in front of it is positive. So I said that it looks something like this, right? Where if I were graphing this, as x approaches, so there's two ends you have to describe, and you have to do it this way. As your x value approaches positive infinity, so you're going this way, what does the y value do? What are these y values? Where are they going? They're going up towards positive infinity. Okay? Now, as you plot x values going towards negative infinity, where are the y values going on that end? All these y values are going towards negative infinity. So up is positive infinity, down is negative infinity, left is negative infinity on the x, and to the right is positive infinity. So both of these are part of your end behavior. You have to write it like that. Okay, look at letter B. Sketch the little graph. Is that an even or an odd graph? It's even. And which way is it going? Is it, if even, both either going up or both sides are either going down. So where's this going? Both of these are going down. It's a parabola going down. So if you were to describe, here's the right-hand side, here's the left-hand side. Okay, let's start with the right-hand side. As x starts to plot points going towards positive infinity, so I'm plotting points here, where are the y values getting plotted? Y is approaching what? Negative infinity. It's going down. All these points are going down to negative infinity. That takes care of the right-hand side. What about the left-hand side? As x starts approaching negative infinity, like you're plotting points towards negative infinity, where are the y values going? Y values are going down to negative infinity as well. So you have to write both sides of your ends of your graph as your end behavior. I only drew the sketch because it's just a visual for you. Okay, what about letter C? Is that even or odd? That's odd. And it's a negative. So that means it's going to go in the opposite direction of this first one that was odd. So it's going to go like that. Okay, so let's do the right-hand side. As you start plotting points going towards positive infinity, so as x approaches positive infinity, what are the y's doing? Going down to negative infinity. Okay, left side. As x approaches negative infinity, as you're plotting those, where are the y values going? Positive infinity. So that's how you're going to write your end behavior. You have two ends, so write two parts. Okay, what kind of a function is this, even or odd? Even and negative, so which way are they going? Both going down. So the right-hand side, as x approaches positive infinity, where are the y values going? Both going down. As x approaches negative infinity, the y values are also going down towards negative infinity. Okay? So you'll have to do end behavior based on an equation, which you don't have to graph if you know what it's going to look like. You don't have to graph those. Just maybe sketch a visual if you want. Okay? Now, the last part, they will give you graphs, That'll be easy because they're showing you what it looks like, and you do the end behavior based on the graph. Okay? So let's look at a few of those, and then we should be finished. Okay, so we're just still describing the end behavior of each of these graphs. Okay, so this one is even because both are going in the same direction. And what power is it? How many turns does it have? 1. It turned around here. 2. 3 turns. So this must have been x to the 4th because 1 less is how many turns it has in the graph. But that's okay. We already know it's negative x to the 4th. So as x approaches positive infinity, what are these y values doing? They're going down to negative infinity. That's the right-hand side. Left-hand side, as x goes to negative infinity, as you're plotting points here, where are the y values going? Also negative infinity. This one, 1, 2, let's see. There's 1, 2, 3, 4. No, you can't see all the turns. So we're not going to really tell what that is. We already know it's even because both are going in the same direction. So end behavior would be as x approaches infinity, the y values are going towards infinity. And as x approaches the negative infinity, the y's are going up to positive infinity as well.